Hello, my name is Andres Sorta, and today we'll be talking about the glycerol 3-phosphate shuttle. So, when recalling glycolysis, we see that oxidation of glyceraldehyde 3-phosphate by glyceraldehyde 3-phosphate dehydrogenase produces two NADHs. So, as we have already covered, glycolysis occurs in the cytoplasm outside of the mitochondria, and the NADH molecules cannot pass the impermeable mitochondrial membrane. So under aerobic conditions, these molecules are actually used in the mitochondria in the electron transport chain to produce ATP via their oxidation. So one of the ways that NADH molecules are transported into the mitochondria is by the glycerol 3-phosphate shuttle, which is what we're talking about today. So there's other shuttles like the malate aspartate shuttle. However, we're focusing on the glycerol 3-phosphate shuttle today, and what makes this shuttle unique is that it's specifically used in skeletal muscle and brain cells. If we were to zoom in to where these set of reactions occur in the mitochondria, we would zoom in right here. What we find is the inner membrane space on one side of the lipid bilayer and the matrix on the other side. To begin the first reaction, we have NADH and a proton from glycolysis, which reacts with dihydroacetone phosphate to create glycerol 3-phosphate. So as you can see, dihydroacetone phosphate is actually reduced. This double bond is broken and the two hydrogen bottom atoms are attached over here. This reaction is catalyzed by the cytosolic glycerol 3-phosphate dehydrogenase. The products being NADH+, which can actually go back to glycolysis and form more NADH. So in the second step, we find the mitochondrial glycerol 3-phosphate dehydrogenase. This enzyme is an isozyme of the previous glycerol 3-phosphate dehydrogenase. However, it is membrane bound. An isozyme is an enzyme with a set of different amino acids that catalyze the same reaction. So these two enzymes both catalyze the dihydroacetone phosphate to glycerol 3-phosphate. However, the mitochondrial glycerol 3-phosphate dehydrogenase has a set of amino acids which creates a hydrophobic region that allows it to be membrane bound and part of this hydrophobic area that we find in the lipid bilayer. So going back to the reaction, glycerol 3-phosphate is oxidized by this membrane-bound enzyme, and the two hydrogens found here are attached to the FAD, which is reduced to form FADH2 and dihydroacetone phosphate. So in the final step, we see that FADH2 is oxidized back to FAD, and the two protons and electrons that originated from NADH from glycolysis are transferred to ubiquinone molecule. So this ubiquinone is reduced to ubiquinol, and now it is inside the mitochondria, and it will actually go on to complex 3 of the electron transport chain, bypassing complex 1. So due to this bypass of complex 1 in the ETC, we find that NADHs from glycolysis actually yield a net result of 1.5 ATP molecules per NADH, in contrast to the 2.5 ATPs from NADH formed from the TCA cycle. This is due, again, to the bypass of complex 1, which would generate the pump of 4 protons into the inner membrane. So in conclusion, we find that the glycerol 3-phosphate shuttle allows the transfer of electrons from NADHs from glycolysis into the mitochondria to be used in the electron transport chain to generate ATP. Thank you for watching.